right, we're going to be finding the greatest common factor. This isn't just some little podunk thing that we're going to learn and then go on. This is something you're going to use probably at least for the next month, maybe 2. Okay, this is the very first step in factoring our polynomials, which is big in algebra, being able to factor polynomials. Don't get all bogged down in that. Just like you do in my class, let me teach you one little thing at a time, and I'll combine it with something else later and something else later, okay? So we're going to find the greatest common factor. Now, when you do, some of you will start to be able, with these small numbers, you'll be able to just look and find the greatest. Greatest means the largest. Factor means there's a difference between factor and multiple. So be sure you're aware of this. We will be finding least common multiples later. Greatest common factor is very important right now. So the difference between factor and multiple is that the multiple, it takes a number times 1, and then the same number times 2, and then the same number times 3, and so on, okay? So the multiples of 5 would be 5, 10, 15, 20. Those are multiples. Now factors are what a number is divisible by. So you'll find out that what we're dealing with today is going to be factors. We need to know the greatest, biggest, greatest common, that it's the same in both numbers, factors. There are 2 ways that you can do this. Now, your worksheet has you do it one way. I'll show you the other way. It's pretty much the same, but you might see one of those as easier. Now, on your worksheet, it has you list the factors of each number. So if we want to find the greatest common factor between these 2 numbers, then we need to find all the factors of 4, and then we need to find all the factors of 8. Now, the easiest way to do this is I say, okay, what times what gives me this? So I'm going to say 1 times 4, right? 1 times 4 gives me this. And then does 2 go into it? Yes, 2 times 2. And so in this case, 1, 2, and 4 are the factors for 4. Then I try to find the factors for 8. I have 1 and 8. 2 will go into it. 2 times 4. Will 3 go in? No. 4 will go into it, but I already have the 4 times 2 listed. So that's all the factors of 4 and all the factors of 8. Do y'all see? Okay. So now what we do is look through the list and find the largest number that is in common, greatest common. Okay, so the largest number that's in common with both of these would be the 4. See, this is a common factor, and this is a common factor, but we want the greatest common factor. So the GCF for these will be 4. Now just concentrate on being able to get the GCF for now. And if we get far enough, I'm going to show you what we're going to do with the GCF. Any problems here? Okay, let me show you the other way that I was taught. I think I was taught to find the GCF of 4 and 8. We do the factor tree. 4 and 8. So I do 2 times 2. Those are prime, remember? And then 4 times 2 here. And this breaks down to 2 times 2. Now the greatest common factor will be the numbers that match between these two. Not groups like we did before, but numbers that match. So the GCF here, I see that this 2 matches this 2, so I have a 2. And this 2 matches this 2, so I have another 2. There's nothing that matches that, so I can't use it. So the greatest common factor is 4. Okay? Either way is going to work just fine. And you can choose which one you want. But this first page, this page 1, asks you to list the factors and then circle the largest one. Okay? Let's do another one on that first page just to make sure that we're clear. And let's go down and pick 24 and 6. 24 and 6, that's number 4.
What paper is it?
Oh, I am sorry, Wyatt, you didn't get it. Do you want to run up here real quick? And thank you for this. There's also a set of rules that you need to sign. There's a copy for me to have with your signature on it in that set. And then one, let's see. That was yesterday. This is today. Okay. This is today. Let's go ahead and get you these so we don't have to remember what ones. You need a 3. This is number 3 in a minute. Good heavens. Packet 3 and packet 4. We have a packet 5, but I haven't decided yet if I want to use it. So 24 and 6 is what we're going to try. And maybe y'all have started, I hope. Yeah. Okay, 24 and 6, and they want the greatest common factor. So on this worksheet, they're going to want all of the factors of 24. So I like to start at 1, then go 2, 3, 4, until I see a repeat. So 1 times 24. 2 will go into it. 2 times 12. 3 will go into 24. 3 times 8. And then 4 will go in times 6. 5 will not divide into here, but 6 will. Okay, but we've already have 6 listed, so I know I have all the factors. Do you see how I do that? You start 1, 2, 3, 4 until you see a repeat. Okay, let's go with 6. I have 1 and 6. I have 2 and 3. And the next one would be 3, but I already have that listed. So this is all the factors of 6. So now I'm going to look and see if I can find the greatest common factor. And it looks like 6. All right, now the other way. Let's do 24 and 6. So you can start anywhere you want to with the factor tree. I have 2 and 3 and 2 and 2. This is called prime factorization. We call it a factor tree because it looks like a tree. 2 times 3 here. We circle when we get down to the bottom, and each one of these is prime, and that's how we know that we're finished. Okay, so the greatest common factor. I match numbers. So there's a 2. And I know there's a 3. We multiply the numbers that we have. These don't have a match over there. And so our greatest common factor, I'm sorry.
That would be 2, right?
2 times 3, because there's a 3 that matches. Do you see?
Yeah.
So you do 2 times 3, which makes the greatest common factor be 6, just like it was in this one.
Yeah.
So either way that's easiest for you is fine with me.
Can you not just do the factors first?
Yes, you don't have to do both. I'm doing both depending on which one you guys like. You need to see both of them. Okay, and even on this page, if you don't want to list the factors, you can do the factor tree. Just as long as you can find the greatest common factor, I'm fine. All right. Let's look. Any questions on that page? Shaniqua is coming in. Okay, page 2, you're going to be doing exactly the same thing. All they did is give you a little bit bigger numbers. This is page 2. Just a little bit bigger. No big deal. Do it exactly the same way. And then again, they just show you, they just show you how they write it now, which means if they're wanting the greatest common factor of these two numbers, they're actually going to note it as they want the greatest common factor of 24 and 6. Okay, that's the way you're going to see it written. And that is what you're dealing with on page 3, which means you're going to be doing exactly the same thing. Again, it's important that you know how to find the greatest common factor. Very important. And after you start to use the method to find the greatest common factor, a lot of it will come easily to your head. You know, you'll go, oh, I know what that is without doing the work. Okay. And when you get there, I'm fine. Page 4. Same thing. Notice that I know how much practice you need. Okay. Now, page 5, the only difference here is there are 3 of them. Let's just do one. 18, 6, and 24. 18, 6, and 24. So, exactly. Did I get you in, Shaniqua? Good. Are you with me?
Yes, ma'am.
Okay. Good, good, good. I hope you didn't have to wait on me too long. All right. So if I list the factors again, I'm going to do it 2 ways. There's 1 and 18. 1 times 18. 2 will go into 18. 2 times 9. 3 will go into 18. 3 times 6. Well, 4, 5. So 6 is the next one. It's already listed. So that's all the factors of 18. 1 times 6. 2 times 3 are the factors of 6. And now we have 1 and 24. We just did this one. 2 and 12. 3 and 8. 4 and 6. 5 won't go in there. I did 1, 2, 3, 4. 5 won't divide evenly into 24. The next one is 6, and I have all of them. So now you're just going to look and see what the largest common factor is. And if you'll notice, I can't go larger than 6. Y'all see? The smallest number, the greatest common factor, can't go bigger than this because that's the largest factor here. So I'm going to look and see if it's common in all of them. And here we go. Okay, so 6 is the greatest common factor here. Let's do the T-chart real quick. 18, 6, and 24. 3 times 6, 2 times 3, 2 times 3, 12, 4 times 3, 2 times 2. So I have to find the ones that match. So my greatest common factor is going to be simply the factors that match. So do I have a 3 in all of them? Okay. If I have a 3 that matches in all 3 of them, then I can use a 3. There's a 2 and a 2 and a 2. I have another 3, but it can't match here, can't match here. I have another 2 here, but it can't match here and here. So my greatest common factor again is 6, no matter which process you use. Okay, so 3 isn't any different than finding the greatest common factor with 2 things. All right. So that, believe it or not, we're already through page 5. You'll get a lot of practice by the time you get there. So I am going to move on to page 6 and 7. Let me see if I'm going to go to 8. Yeah, 8 is going to be the same as 7. And 9, the same. Okay, so let's go to page 6. Now in this case, they not only have numbers, but they have the variables with them. The same process is true, the exact same process. So, number 1, on page 6, number 1 on page 6, notice the comma. They want us to find the greatest common factor between. All right? You okay, Shaniqua? You've still got that ugly cough.
Yeah.
Z 2y squared. Okay? So if you break this down, 4 is 2. All the factors. So I've got 1 and 2 and 4, but I also have y and z. Y'all see? Write down the 4. But then I list the variables also. So down here, I just have a 1 and a 2 and a y and a y. And so I want to look for the common number and the common variables.
I'm sorry, I didn't catch the last part. The 2 y's is because of the exponent?
Yes,
Okay.
y times y. Okay, and so this is the greatest common factor of the coefficients. Now I want to use the greatest common variable. So the biggest is just one of the y's. Do you see there's not a common here? So the greatest common factor here is going to be 2y. Because that's the biggest thing that you can divide out of this and divide out of that. And one more time, I'll do this for YZ, kind of the same thing. when we do a T-chart of this, I do the number first. And I have 2 times 2. And I do the number first. That's already 2 times 1. And then I bring down my y and I bring down my z. You see? This one, I bring down my y and my y, which actually looks the same as this. Okay, that's how it's broken down. And then we find the things that are common. So I have a 2 and I have one of the y's. I can't do 2 y's because I don't have another y here.
So we're not doing the invisible one or anything like that? Okay.
The invisible one's there, but we ignore it anyway. So if it helps you to put an invisible one, okay, but we don't use it. So for factor trees or for factors, our greatest common factor, we get the same thing. Yes? Okay, and that's all of that page. Just be really careful. Okay. And then we use that information. Now we're going to start to factor quadratic polynomials. This is page 7. Now they don't have a comma between 2 things. They said, here's a polynomial. I want you to find the greatest common factor. And factorize, I don't know that I've ever heard that word, but it's wanting you to factor this expression. So now we're going to have 2 steps, okay? We're going to find the greatest common factor of 6x and 9. But our second step is where we're actually going to show that we factored it out of this polynomial. So the first part is what we've been doing all along. So this says to factor this linear expression, 6x plus 9, and they want you to factor this. I'll show you what they mean, but first of all, we need to find the greatest common factor between 6x and 9. So I have 2 times 3 makes 6, and then I have an x. I have a 3 and a 3. Those are both prime. And so my greatest common factor here is just the 3, right? That's the only thing I have in common. Are you able to see around me? I'm right-handed, so this is what I always do. I try to write backwards. This is important for you to know now because we're going to go back up here and actually factor out. Now, when we factor something out, that means we're actually going to divide it out. So when you're going to factor this, we're factoring out the greatest common factor. We found that it's 3. You have to find that first. We're going to write the 3 and then open a set of parentheses, and we're going to write what's left after I factored the 3 out of here and after I factored the 3 out of here, which means after I divided the 3 out of here, what's left? After I divided the 3 here, what's left? So 6x, but I divided a 3 out. What's left? 2. Did I factor the x out? No. So there's still an x left also, right? And then I'm going to use the plus. Now I have the 9, but I factored or divided out a 3. What's left?
A 0.
What?
A 0. There's nothing left. And so a 2 or a 3.
There's a 3 because I factored the 3 out of here. Yes?
Yeah.
Now let me show you a shortcut. If you do this, look, you marked out the greatest common factor, didn't you?
Yeah.
Look what's left.
A 2. And an x.
2x. What's left here?
That's a 3. Okay.
Do you see? Now the way that you can know that you did this correctly is now we're going to go backwards just to check it. and do the distributive property. So if you do 3 times 2x, what do you get? 3 times 2x,
6x.
and then 3 times 3.
9.
If I can do the distributive property here and get what I started with, then my factoring is correct. Not bad?
No.
Okay, let's do another one. Let's see if we can get more things. Like on that page, let's go down to number 10. We're going to be doing number 10 down here. Okay. Okay, it says to factor this. 40b minus 80c minus 40d. Okay, so we need to know here, got 4 times 10, 2 times 2, 2 times 5, and a b. Okay. I have 8 times 10 times 4, 2 times 2, and 2 times 5. And I have a c. And one more time. I have a 4 times 10, 2 times 2, 2 times 5. And I have a d. So my greatest common factor then. So I need to look all the way across. I have a 2. There's some more, right? A 2 and a 2 and a 2. And will 2 go again? Sure enough. 2, 2, 2. No more 2s, so that one's out. But there's a 5 in each one. 5, 5, and 5. Let's look at the letters. Do I have anything that matches? B, C, D. I can't use any numbers this time. I mean, variables. So I have 4 times 2 is 8 times 5. So my greatest common factor is 40. And then we go one more step because it says now I need to factor out that 40. Up at the top it says factorize this. So I have to show what this looks like when I divide out the greatest common factor. Greatest common factor is 40. So I write the 40 out front. That's what I'm going to divide out of each piece. So this piece right here, when I divide a 40 out of there, what have I got left? A B. Oh, invisible 1, but a B, right?
Okay.
And I'm hearing you guys online too. That's good. Then I use the sign. What have I got left when I divide this 40 out of here? 2C. And minus, and when I divide 40 out of here, a D, 1D. And this is our first step in factoring polynomials. First and probably the most important step. Okay. We divide the 40 out of each piece. Now let's check and see. All that was left was a B, right?
Uh-huh.
All that was left C, 2C, and all that's left here is a D. Okay? So this is a good way to check. This is a good way to understand what's happening. The greatest common factor goes out front. And then we have a parentheses full of what's left in our polynomial after it is divided out. Yes? Are we
Yes.
okay with greatest common factor?
Yes, ma'am.
Let's look. Thank you for your all's participation. I like to hear from y'all. Let's look at page 8 and page 9. We're going to do one on each page. So on page 8, do you see one that you would like to see worked?
Let's do 9.
Okay, number 9 on page 8, y'all. Number 9 on page 8. So I have 16 UV plus 8 UW. And I want to factor these. They call it factorize. Strange word. Okay, so I have to find 8 times 2 is 16. 4 times 2 is 8. And 2 times 2. I also have a U and I have a V. And I have a 4 times 2, a 2 times 2. I have a U. And so I need to find my common factor. I find things that match. I've got a 2. Now, some of you are going to want to go through here and go here, here, here. But then after you've marked everything off, then how do you know what to write? So I'm serious about this. Mark out one set and write it down. Mark out another set, write it down. Mark out another set, write it down. If you don't, you're going to get mixed up. And the U's are common. Bless you.
Bless you.
So my greatest common factor is 8. 2 times 2 is 4 times 2 is 8U. So that is what I'm going to factor out or divide out of this polynomial. When I divide an 8 out of 16, what's left? 16 divided by 8.
2.
I have a 2 left. And I also factored out the U. So it's not there, it's out here. So I've got a V left because I did not factor out the V. Y'all understand what I did here? Awfully quiet. Did y'all understand that when I took out the U or divided it out, it's no longer there? But the V, I did not take it out, so it's still there.
Okay.
Because there was a U that was common, so it became part of my greatest common factor.
Oh,
Okay?
that
It's
makes
like
sense.
another.
Yes, it's another thing that goes with it. All of the greatest common factor comes out front. Okay, good. I'm glad you guys asked that.
So if there's like 3 Z's, but and like that's the highest exponent, it's gonna be the greatest common factor, right?
I think that's a yes to what you said. I think. Now I have 8 UW, but when I divided out the 8, that's gone to a 1. When I divided out the U, that's gone, except the invisible one. So what's left here?
W.
This is the factored polynomial. It's when I take out the greatest common factor. Divide out the greatest common factor. Does this make sense to you?
Mm-hmm.
You're doing pretty well. Let's go up to the shortcut where you can check yourself. In the parentheses should be the things that aren't marked off. So in the parentheses, I didn't mark off this, and I didn't mark off this. That's 2B. And over here, the only thing I didn't mark off was the W. So what's left after I mark off stuff is what goes in here. Better? Yeah. Yes. We're going to use the distributive property. And so the distributive property says take what's out front, multiply it here, and multiply it here, okay? Invisible one. So when I take 8 times 2, that's 16. But I also have a U and a V in these first terms, U and V. Then I put a plus. 8 times 1 is 8. And I still have a U and a W. And if you compare this with your original problem up here, they should be exactly the same. Yeah. Good question. This is how you check it to make sure you did it correctly.
So this is really, it's all the same, all we're doing really different is the letters or the exponents to make it 3Ys or 2Ys.
You're exactly right.
Okay.
This whole packet, pretty much the same thing. But as I promised, let's go to page, is it 9?
Yes.
Page 9. And let me pick out one there because I want to make sure we use exponents this time. They just used more variables on page 9, but nothing different. Everything's the same. They just made a little bit larger polynomial for you so that when we factor it down, maybe we have to put 2 Ys or 3 Bs or whatever.
Yeah, it's the same thing, you're just adding into it.
Exactly the same thing.
Yeah.
So let's go to, I want to do one that looks really scary. Well, do they all look
9?
scary? I see 3 and 7. 3 or 7, which one?
Let's do 7.
7.
7.
60. X, y to the 5th. Z minus 80.
Oh, that is scary.
X squared, yes. X squared,
Looks scary, would it be?
y to the 4th. It shouldn't look as scary as it did before I started today.
This one looks easy. Number 7 looks easy because it's just those are the 60s or 70s, the 80s, so you can go into that a little bit easier. Like,
Yes. When you do your factor tree, I know what you're
Yes.
saying. Mhm. So we're just going to do the numbers first, and we have 6 times 10, 2 times 3, 5 times 2, but then we don't want to forget our letters. So I have an X. I have a Y times Y times Y times Y times Y. Y'all see? Because it's Y to the 5th. Do you see why I wrote 5 of them?
Mm-hmm.
Okay. And then I also have a Z. So I factored this whole thing. that sideways here. So I'm going to factor the 80. I've got 8 times 10, 2 times 4, and 2 times 2, 5 times 2.
See?
Then I have an x and an x because it's x squared. I have a y times y times y times y. And I have a z. So it looks like it's going to be a pretty good size greatest common factor, right?
Mm-hmm.
So let's start. It's only 2 that we have to find matches in. So I have a 2 here. No 3s anywhere, right? No 3s.
No.
So I can't do that. What about 5s? Yes. I have a 5 and a 5. Yeah, another 2 and a 2. And I didn't have a 3, so I can't match anything else. This is it. So now I'm ready for my variables.
Mm-hmm.
X here and an X here. That has more X's, but this one doesn't, so I can't do anymore. Let's go for Y's. I have a Y here. I have a Y here. I have a Y here. And a Y here. Here's a Z. Do I have any? Oh, I do. And I have a Z. So my greatest common factor, 5 times 2 is 10, times 2 is 20. Y to the, oh, no, X. I have an X. Y to the 4th. Z. All of that is my greatest common factor. Just put it up a little ways so everybody can see. So my greatest common factor is 20 xy to the 4th z. Since that's my greatest common factor, that goes out front, and then I open parentheses to tell what's left in my original polynomial after I divide this out. I'll try to get on the other side. So 60, but I divided out 20. So what's left? 60 divided by 20 is
3.
3. Now it did have an x, but I factored an x out, so there's no x's, right?
Mm-hmm.
Y to the 5th, and I factored out 4 of them.
So you got 1.
Still have a y left, right? Because there were 5 of them. I took out 4 of them.
Right.
Yes, y, right here. And then z, it had a z, but I factored out a z, so nothing, right?
Mm-hmm.
I'm done with that one. I'm at the minus sign. I'll get rid of this so it's not confusing. Okay. Then I had 80, but I divided out 20. 80 divided by 20 is
4.
4. I had an x squared, that means 2 of them, but I took 1 of them out.
So you got an X.
An x, right?
Yes, ma'am.
I had a y to the 4th in the beginning, that's 4 of them. I took 4 of them out. No y's at all, right? I had a z, but I factored out a z. So there's no z, right? There's your answer. This is the factored polynomial by pulling out the greatest common factor. Y'all see?
Yes,
It's
ma'am.
not a different process, it's just longer. There's more stuff, but we follow the same rules, okay? And again, look at the 60, look at our factoring here. If you can see it, the only thing that's not marked out is this 3 and this y. 3y?
Yeah.
The only thing not marked out here is this 2, and this x.
Yeah, I'm confused
And the
about-
void?
I'm sorry?
I'm confused about one thing, so like,
Okay.
what do you, like, how do you know to mark out, like, what?
What to mark out
Yeah,
is if you have a match.
okay,
There's a 2 here, and if you've got a 2 over here that matches, you can mark that out and write a 2.
okay, so if it matches with the other.
Yes, it has to match with however many, in this case, 2 of them. If there's 3 of them, it has to match all the way across
Okay, so
before
like,
you can write it.
so if it's big enough, they could be like 8 pairs of 2.
Yes, that's
Okay.
possible. Yes. And so over here, I was showing you that this wasn't marked out, so that's 4. And that X wasn't marked out, and that's what's left. How do we feel? Full of it? Okay, but enough that you can start and ask questions? How about you, Shaniqua, Sherry?
I know you made it easier for me to find the GCF. I used to
Good.
hate it.
Yay. Sherry, are you okay?
Easy.
Yes, ma'am.
Okay. I can tell by your voice you're really not, but you're paying attention. So
Yes, ma'am.
are you going to want to stay on today, or are you going to need to go?
I think I'm gonna get off and go lay down and just come back. I understand what you're doing, so I'm okay.
Okay, that sounds fine.
It
I'm
seems-
finished.
It seems a
For
lot easier than what we were doing yesterday, so